and electrical cables, fuel lines, and storage tanks. Most areas have established a digger's hotline number. One phone call is usually all it takes to find out if any underground installations exist. If so, the proper steps for relocation must be followed. Once underground utility lines have been located and removed, safety above ground must be established. Scan the excavation site, noting the location of large rocks, trees, sidewalks, fire hydrants, overhead power lines, phone cables, or other obstacles. These should be removed or secured. OSHA requires that a competent person inspect the excavation and adjacent areas at least once a day for possible cave-ins, potential failures of protective systems and equipment, hazardous atmospheres, or other hazardous conditions. The competent person has authorization to take prompt corrective measures to eliminate any hazards and may be responsible for coordination and direction of emergency response procedures if needed. Large operations should have a full-time safety official who makes recommendations to improve on-the-job safety. In some operations, a supervisor may act as a part-time safety official. Your company policy will give you specific information about how to handle specific problems. Safety is the #1 priority. At the excavation site, soil and rock deposits must be classified by a competent person as stable rock, type A, type B, or type C. This is done to help determine which type of protective system will be used in the trench. This determination must be made at the job site based on the environmental conditions in the field immediately before work begins. To make this decision, at least one visual and one manual analysis of the soil is needed. The competent person may also take a core sample, which may reveal the existence of 2 or more soil types. Cohesive soil remains in clumps after being excavated. Granular soil, on the other hand, breaks up easily and does not stay in clumps. Stable rock is natural solid mineral matter which can be excavated with vertical sides and will remain intact while exposed. Type A soil is cohesive with an unconfined compressive strength of 1.5 tons per square foot or greater. Examples of type A soil include clay, silty clay, sandy clay, clay loam, silty clay loam, and sandy clay loam.
Unconfined compression strength is a measurement of the soil's ability to stand by itself and to support itself without any protection or support. And when the ground is in its normal state before it's excavated, everything is in equilibrium. And when you excavate, those pressures are removed, and this is one of the things that causes cave-ins, because these lateral pressures and the Mother Nature is out of equilibrium, and the walls fall in.
Type B soil is cohesive soil with an unconfined compressive strength greater than 0.5 tons per square foot, but less than 1.5 tons per square foot, or granular cohesionless soils. Examples include angular gravel, which is similar to crushed rock, silt, silt loam, sandy loam, and in some cases, silty clay loam and sandy clay loam. Type C soil is cohesive soil with an unconfined compressive strength of 0.5 tons per square foot or less, or granular soils including gravel, sand, and loamy sand. Other types of type C soil include submerged soil, soil with seeping water, submerged unstable rock, or material in a sloped layered system. If you are ever unsure of the exact soil classification, it should be treated as type C. It is not uncommon to have an excavation site containing a combination of soil types. Every location differs. That's why soil classification is so important. Once the soil classification has been made, you will know which protective support system should be used in the trench. OSHA requires that in all excavations, employees exposed to potential cave-ins must be protected by sloping or benching the sides of an excavation, supporting the sides of an excavation, or placing a shield between the side of the excavation and the work area. The protective system, in turn, must be one that has been designed according to OSHA standards. There are 2 instances, however, when a protective system is not required. The first is an excavation made in stable rock that is not fractured. The second is an excavation that is less than 5 feet deep. This site must be inspected by the competent person, and the determination made that there is no indication that a possible cave-in will occur. Using the sloping method, the sides of the trench are angled away from the excavation in order to prevent a cave-in. Benching uses a series of horizontal levels or steps to keep the wall of the excavation stable. The angle formed by the steps is determined by the soil type. Table 1 in the OSHA Excavation Standard Handbook lists the maximum allowable slopes for all soil classifications. In a stable rock excavation that is less than 20 feet deep, the maximum allowable slope is 90 degrees or vertical. In soil type A, the maximum allowable slope for excavations less than 20 feet deep is 53 degrees. This means that for every 3/4 of a unit covered horizontally, the vertical rise should be 1 unit. The angle of the slope measured from the toe or outermost edge of the excavation will be 53 degrees.
When people talk about the maximum allowable slopes, which is a method of protection when excavating, it's really important that people understand how this is measured and what the whole function of this is. The soil has the ability to support itself based on the unconfined compression strength, and all sloping does is take weight off the slope or off the soil, brings it down into that unconfined compression strength range. So in essence, the soil supports itself. Some common mistakes are people will measure that from the center of the excavation instead of from the toe, which is the outside of the bottom edge of the excavation. And this is, all the slope is a ratio from rise to run.
In soil type B, the maximum allowable slope for excavations less than 20 feet deep is 45 degrees, or 1 horizontal unit to 1 vertical unit. For soil type C, the maximum allowable slope is 34 degrees, or 1.5 horizontal units to 1 vertical unit. When an excavation contains layers of different types of soil, the usual sloping requirements must be varied. The layered system must be classified according to its weakest layer. Table 2 in the OSHA Excavation Standard Handbook lists sloping requirements for layered soils. When layered B over A, the type A layer must be sloped 3/4 to 1. The type B layer must be sloped 1 to 1. A C over A layer would have a 3/4 to 1 slope on the A layer and a 1.5 to 1 slope on the C layer. Here are the proper sloping configurations for other mixed soil types. C over B, A over B, A over C, and B over C. When working in a sloped or benched trench, some practices should be followed. You should never work on the face of a slope or bench above another coworker. This is only allowed after a protective system has been put in place to prevent materials from falling into the trench. If the excavation is 4 feet deep or more, an exit must be provided. The exit must be within 25 feet of every worker in the trench. Common types of exits include a stairway, ramp, or ladder. If used, the ladder must be secured and extend at least 36 inches above the landing. Another type of protective support system used in trenching and shoring excavations is a shield. Shields are commonly referred to as trench boxes or trench shields. Before using a shield, it should be inspected for damage or defects. If any problems are suspected, they should be reported to your supervisor or the competent person, and the shield should not be used. Several types of shields are manufactured for use in specific size trenches. Make sure you are using the proper shield. When installing a shield, the guidelines listed by the manufacturer should always be followed. Overloading the system could lead to a cave-in. You should never be inside a shield when it is being installed, removed, or moved vertically. A protective barrier should be in place to guard you from falling materials when you are entering and exiting the shield. Excavation is permitted below the bottom of the shield, but only to a depth of 2 feet, and only if the shield is designed to resist the forces calculated for the full depth of the trench. There must also be no indication that soil will become loose, either from behind or below the bottom of the shield. Although not commonly used today, another type of protective system is shoring. Shoring is defined as a structure that supports the sides of an excavation and is designed to prevent cave-ins. A shoring system can either be made of timber, aluminum, or other suitable material. Designs for timber shoring fall into one of four methods: requirements set forth by OSHA in the excavation standard, data provided by the manufacturer of the support system, other tabulated data approved by an engineer, a system designed by a registered professional engineer. Placement of the uprights, the vertical members of the system, and the wales, the horizontal members of the system, is crucial to achieving a proper shoring system. The OSHA excavation standard contains several tables showing proper design specifications for timber shoring systems. Aluminum hydraulic shoring is a pre-engineered shoring system consisting of aluminum hydraulic cylinders used in conjunction with vertical and horizontal rails. As with timber shoring, there are four methods that can be used to design an aluminum hydraulic shoring system. The first utilizes data from the manufacturer. The second uses OSHA specifications found in the excavation standard. The third method is to use tabulated data approved by an engineer, and the last is to have a registered professional engineer design the system. When it comes to a shoring system, there are several safety rules that you should be aware of. Make sure to coordinate the installation of the protective support system with the excavation timeline. An open trench with no support system in place is an invitation to disaster. When installing the shoring system, do so from the top down. Removal of the system should begin at the bottom.
It's very important to remember when you're using shoring equipment or cave-in protection systems that there is a proper method for installation and removal. When you install shoring, it should be installed from the top down. That way the individuals or the employees involved are not going to be exposed to unprotected excavation. And the same goes for when you're removing these protection systems, the theory being that as you remove them, you're moving up the excavation towards the top, and you actually work yourself right out of the excavation. So it's all based on the employees never being in an unprotected environment.
If at any time a support member must be moved, a backup structural member should be installed. All protective systems should have the strength to resist all intended or expected loads. The system should never be overloaded. As soon as the support system has been removed from the trench, it should be backfilled. Teamwork is a key to safe trenching and shoring activities. Everyone must be aware of their surroundings and do all that is possible to keep the work area accident-free. Now let's review some common safety practices. Know your job responsibilities. If at any time during the excavation process a question arises, don't hesitate to ask a supervisor or the competent person for an explanation. A few minutes of downtime could prevent a serious injury or accident from occurring. Make sure you and all your coworkers have and use the proper safety equipment as required by your individual company policy. These items may include comfortable yet reasonably tight-fitting clothing, eye and ear protection, a respirator, safety belt, safety shoes or boots, and a hard hat. When working in an area that is near traffic, all workers should wear bright orange vests. If necessary, a flag operator should help keep traffic flowing smoothly. A warning system should be in place to identify the location of the trench. Barricades, mechanical signals, and fences are just a few examples. If a walkway or bridge goes across the trench, fall protection must be in place. This should include a guardrail and tow boards. Changing conditions can quickly alter the safety considerations in a trench. If a heavy rainstorm passes through the area, the competent person should inspect the trench before work resumes. Exposure to water could weaken the physical characteristics of a particular soil type. Under no circumstances should surface water be allowed to enter the trench. If you see standing water, do not enter the trench unless adequate precautions have been taken to protect you from hazards created by the accumulated water. No member of a trenching and shoring crew likes to think about an accident. But when tragedy strikes, the passing of time becomes the enemy. Under the guidance of a safety director, your company should develop a specific emergency plan which addresses every type of possible emergency. Your familiarization with this plan is the first step toward a quick and efficient rescue. Some common points to be covered in the emergency plan include immediate notification of the authorities and rescue personnel, usually via the 911 system, and what the responsibilities are of those working in or around the accident site before and after the rescue team arrives. Trenching and shoring. In the construction industry, it's a job that brings with it a great amount of responsibility. But knowing and understanding rules and regulations and company policy can help keep you and your fellow workers safe.
Just bear with me for a moment. Got some pictures here. It's picture time. Yes. All right. So I'll just keep it basic for this morning because I know you guys are probably pressed for time and want to get out there and get working, but this is a big deal. Trenches and excavations, they're one of the most easily cited issues dealing with OSHA today. You know, besides fall protection, it comes down to trenches and excavations. Now, make it very simple, very easy. Trenches, at 4 feet, you got to have egress, whether that's a ladder or whether that's a low sloped ramp going up out of the actual trench. At 5 feet, you have to have cave-in protection. Now, these are no ands, ifs, or buts. You have to have it in place. If you don't have it in place, you're not within compliance. Now, there's a difference between being in compliance and also being dangerous. And I got a couple of pictures here I want to show you. And I just took these, there's my truck in the background, but I just took these the other day. And what do you think? What are your thoughts? What's missing there?
Trench box.
Trench box. I mean, look how deep it is and look how narrow it is. You think anybody was in there? Of course. I'll just take a look at it. You know, they've already got pipe in the ground right here, and they got this hanging out right there. And there wasn't a single trench box on the site to be found. Okay, something like that is incredibly dangerous. And I actually spoke with the guy and said, do not let anybody go in there until you get a trench box out here. Oh, well, you know, we don't have one on site, and, you know, I got to rent one. I don't care. You know, rent one. Do something else. Like, if there's something else or some other task you can perform other than putting somebody in that trench, do that. Because it could only be a matter of time before that stuff falls in and somebody gets killed. And that's deep. So if all that earth comes in there and covers somebody up, it's going to take you a while to dig them out. And during that time, you know, like they said in the end of the video, time is of the essence when you got somebody that's covered up, because basically they're just suffocating to death. You know, and if so, you know, an excavation like that deep, you know, it basically becomes a recovery instead of a rescue. You're not going to rescue anybody. Not only that, if your emergency response is to call the fire department, call emergency medical services, what are they going to do that you can't? You know, are they going to bring their own excavator out there and start trying to dig the guy up? You know, are they going to jump in the hole? Probably not. So that's why it's up to you guys to be able to respond quick enough so that you can save somebody if they need saving. So, no trench box, sheer sides, no egress, very bad situation. There we go. All right, now here's another job. Not necessarily too deep, but it's at about 5 feet. Would you consider that dangerous? Probably not. Probably not, because it's the trench is about, you know, anywhere between 5.5 feet, anywhere between 5 to 6 feet.
With rocks and egress.
There's no egress and there's no cave-in protection. Like I said, you have to have cave-in protection at 5 feet, no matter what. Even if it's a trench just like this, where it's not that deep, still at 5 feet, they say this is what you have to have in place. If you don't have this in place, you could be cited for an OSHA, for a citation from OSHA. So, I mean, safety is the number one goal here, but you also have to understand that you can get fined for some of the stuff. You know, I mean, people get fined for situations just like this, where there was actually one job about a year ago. I think I told you guys this story. Compliance officer came onto the job and basically measured the trench from the lowest point up to the top, and it was 5.1 inches, and they cited the company, I think it was $5,000, because it was 0.1 inches over the maximum height, over 5 feet, which is crazy. But you know what? You got sticklers like that too. And some of these guys, these compliance officers, they'll sit out and they'll hang out all day long and just take pictures all day long so that they can get you. So this would be a scenario where it's not necessarily dangerous, but it's incompliant. Just going back to the other one. That was a bad one. Really nasty. There we go. What else do you see here? Just out of curiosity. Dirt's got to be far enough back. Dirt's got to be 2 feet from the edge of the excavation. 2 feet. Because say, for example, this is, let's say it's 15 feet or 12 feet. If you got this right up against the edge here, and this is 3 feet high, and let's say, it's 15 feet deep, you add another 3 feet on there, and now it becomes 18 feet deep in their eyes. Not in yours, but in their eyes, but in OSHA's eyes. Dirt's got to be pushed further back. I don't know why it's doing this to me, but anyhow. Perfectly good ladder. Was not in the hole. Okay? Cave-in protection at 5 feet. No less. Egress at 4 feet. Okay? Everybody got it? Yep. Okay.